to determine experimentally the metacentric height of a ship model written. Please reply, otherwise I will proceed further.
Yes, sir, written.
Okay. Experiment number 2. To verify experimentally, to verify experimentally the Bernoulli's theorem. Experiment number 3. To study the flow parameters, in the bracket laminar and turbulent bracket close for flow through a pipeline. Experiment number 4. To study the losses due to friction in pipes. To study the losses due to friction in pipes. Experiment number 5. To study the discharge over different types of notches. Okay. So we have 5 experiments. Now I am going to show the setup of the all experiments. First we have this is the setup of our first experiment, that is metacentric height. And this is the apparatus. Okay. This is the apparatus, means this is the tank, and this is our ship model. Keep it here. This is the ship model, and we will place this ship inside the tank after filling the water in it, and we will study about this, and we will calculate the metacentric height. Okay. These are the free weights by which we will calculate the whatever the oscillations which will happen due to the, if the weights will move from that center to the outwards. Okay. And this is the first experiment. After that, the second experiment is about the Bernoulli's theorem, and this is the apparatus of Bernoulli's theorem. We have to verify the Bernoulli's theorem. This is the apparatus. This is the tank in which we will measure the flow of the discharge, and these are the all the manometers at different sections. We will calculate the pressure by these manometers. I think you are able to see the readings on these small pipes. Is it visible to all you guys?
Not clearly, sir.
No sir, focus नहीं हो पा रहा.
Okay, okay. And this is our third experiment, that is Reynolds experiments. This is the Reynolds experiments. Can anybody tell me about why we calculate Reynolds number? Means what is the significance of Reynolds number? Anybody can reply?
To determine laminar or turbulent flow.
Yeah. We decide
Nature of
whether
flow.
the flow is laminar or turbulent. Okay. So in this there is a pipe. Okay, and here is one that tube in which we fill the dye, and the dye comes from this small pipe, and this dye is inserted in this pipe. Okay, when we do experiments now, we will actually see, and when the dye will come from this pipe, and also the water will flow with the dye. And if the dye is very smooth, means dye is appear very smooth and in one line, we can say that it is laminar. And if it's in uneven and in zigzag motion, we call it as a turbulent. And if the dye mixes with the flow, we call it as a turbulent flow. And after that, we will calculate the flow and we will calculate the Reynolds numbers. After that, the third experiment is fourth. Fourth experiment is calculation the friction in pipes. Okay. So the setup is here. This is the setup. This is the huge manometer in which we calculate the pressure. And this is the tank in which we will calculate the by which we will calculate the flow of the flow rate of the flow. So this is the apparatus to calculate the losses in the pipes. After that, the last experiment. We have last experiments on the notches, the flow through the different types of notches. And this is open channel flow setup. And here we fill the water and we let the water flow by these notches. Here you can see that this is a V notch. Okay, are you able to see? This is a V notch, and we can change this setup and we can change the notch by changing the V notch to the rectangular notch or different notches. Okay. So these are the 5 setups on which we have to do our lab work, and we will start our lab work from the next week. So do I have to repeat all those experiments? Means anybody have missed these explanations? So okay, I am going to repeat once again. This is the first experiment, that is metacentric height calculation. This is the ship model, and this is the tank. This is the tank on which in which we will fill water, and we will calculate the buoyancy force by the displacement. Whatever the water will be displaced, we will calculate the displaced water, and by which we will calculate the buoyancy force. And after that, we will move the weights and we will calculate the angles by which the ship is moving, and then we will calculate the metacentric height. And this is the compass. We have that meter by which we can calculate the angle of the tilt of the ship. Okay. And the second, we have the Bernoulli's theorem experiments, on which we will verify the Bernoulli's theorem. This is the setup of the Bernoulli's theorem. We have different manometers at different sections, though we can calculate the pressure at different sections. And also we will calculate the velocity by the calculation of the flow, and we will verify the Bernoulli's theorem. This is the setup of the Bernoulli's theorem. And the third experiment is Reynolds experiment, in which we will calculate the Reynolds number by seeing whether the flow is the laminar or turbulent. And we will verify by injecting the dye in the flow, and if the dye is very linear and which not mixes with the flow, then it is laminar, and if the dye mixes with the flow, we can conclude that the flow is turbulent. And the fourth experiment, we have the losses in the pipes, and this is the setup. This is the setup of the losses in the pipe. We have one manometer to calculate the pressure uh, in the pipe, and by which we will calculate the losses in the pipe. And we have the flow measuring device, flow measuring tank, and by this after measuring the flow we can measure the velocity, and after measuring the velocity and the pressure we can calculate the losses in the pipes easily by the Darcy-Weisbach formula. I think you all have know about that Darcy-Weisbach formula. After that, we have last experiment, that open channel flow setup, by which this is also known as the flow through the notches. We have different notches. Now you can see that this is a V notch, and we can change this setup, and we can set up the rectangular notches or some different notches. This is the tank where we will fill the water and we'll let the flow to come by the notches. And this is the vernier caliper by which we will calculate the height of the water. Means if the water height is more, the flow is more, means we know that this is due to by the gravity. We all know about that. Okay, these are the 5 experiments we have to actually perform for the our lab work, and we will start these experiments from the next week. Any query about all those experiments? Anybody please reply. Do you have any query?
Sir.
No, sir.
Okay. Okay, we are going to take the attendance. So please reply. Uh, can anybody tell that from what roll number you have joined?
From 61, sir.
61 to 122.
122.
Yes, sir.
Okay, okay. Roll number 61,
Yes, sir. Present.
62, 63,
Present, sir.
64, 65,
Present, sir.
66,
Present, sir.
67, 68, 69,
69 present, sir.
69 present,
Yes, sir.
70,
70 present, sir.
71, 72,
Present, sir.
73, 74, 75, 76,
Present, sir.
77,
Present, sir.
78, 79,
Present, sir.
80,
Present, sir.
78 present, sir. 78.
78 present, 81, 82,
Present, sir.
83, 84,
Present, sir.
85,
Present, sir.
84 present.
85 present, sir.
84 present, sir.
Okay, okay. 84 and 85 present. 86,
Present, sir.
87, 88, 89,
Yes, sir. 89.
90,
Yes, sir.
91,
Present, sir.
92,
Present, sir.
93,
Present, sir.
94, 95,
Present, sir.
96, 97, 98, 99,
Present, sir.
100,
Present, sir.
101,
Sir, 100 present.
101, 2,
102 present, sir.
3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7, 8,
Present, sir.
9,
Present, sir.
10, 11,
Yes, sir.
12,
Present, sir.
13, 14, 15, 16,
Present, sir.
17,
Present, sir.
18,
Present, sir.
19,
Present, sir.
20,
Present, sir.
21,
Present, sir.
22. Okay, anybody that has left the attendance?
87. Roll number 87.
87. Okay.
Thank you, sir.
Anybody else?
122 also.
122. Yeah, it's none. Present, you are present. Okay. Okay, from the next week we will start our actual lab work. Today we have that introduction class. So I introduced you all with those 5 experiments, and now we will start our lab work, and we will do some experiments on our experiment setup. And from the next week, okay, so you can leave now. Thank you.
Thank you, sir.
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 हो गया भाई.
Thank you, sir.
आज भी कुछ करना है क्या? फिर से सर ज्वाइन कर देंगे.